3.1 Preparing practice data. The most commonly used tool for simplifying this process is dplyr, part of the tidyverse. We will practice using it. Create Tutor 1 R script and following the tutor book. We will practice creating data tables through the 6th Korean Working Conditions Survey data. You can apply for the materials through the Occupational Safety and Health Agency at the raw data site of the Working Environment Survey, kosha.or.kr/data/dli/data.do. We will load the data. However, for rapid progression of the practice, we will use the file available on the GitHub page. Please check if there is a folder named Data in your own folder. Download it into the folder called Data, and we will load it. Let's take a look at just 10 pieces of data. In this case, head shows the first 10, tail shows the last 10, and slice 515 shows from the 5th to the 15th. The questionnaire and the file describing the variables are as follows. Three 3.2 Data manipulation. 1. Select. Selecting data involves breaking it down by type and columns, essentially segmenting the data by variable names. The variables to be selected can be identified using their names or their variable numbers. Starting from 1 on the left, let's try selecting the first 5 variables. Next, we'll select variables that include the term job. InSelect text within quotes is recognized as a variable name, an important concept. Both of the following commands yield the same result, indicating that text input received externally can be applied directly. To exclude variables, use -2. Filter. Filter selects rows that meet certain criteria. For instance, you can select individuals based on gender or within a certain age range. Several conditional statements are used for this purpose, with equals, equals, double equals signifying equality. Select TSE-XAGE. This selects only the TSA, X, and a GE columns from Q. Filter AGE equals 55. This filters the data to include only rows where AGE is equal to 55. Head, finally, this shows the first few rows of the resulting filtered data. N stands for an. While signifies OR, we can apply multiple conditions at once. Filter TSEX equals 1 and AGE 17. This filters the data to include rows where TSAX is 1, which might represent a specific gender, like males, and a GE is less than 17. Using percent in percent allows selection via listing multiple conditions, convenient for nominal variables. Filter TSEX percent in percent C12. Here, percent in percent is used to filter rows where TSEX is either 1 or 2. The percent in percent operator is particularly useful for filtering based on multiple values in a vector. Filter bang a GE16. The bang symbol represents logical NOT. This line filters for rows where a GE is not greater than 16, effectively including ages 16 and below. 4. Mutate. Mutate is a fundamental function frequently used for transforming variables. It is essential to become familiar with this function. Mutate is often used in conjunction with various conditional statements like ifels, case when, and recode. It is recommended to use case when over ifels for ease of use in future SQL applications. For example, currently 1 stands for male and 2 for female. We will change these to male and female, respectively. Next, we will adjust the age groups to intervals of 5 years and transform the data into a new dataset called test1. In test1, we have sex G as female or male now. We'll change female to female and male to male using their code function. If there are only 2 genders, this method might be simpler. Use case when appropriately with female and male. Now we will classify individuals under 60 as young and those 60 and above as old. And then we will change the categories to young female, old female, young male, and old male. 5. Group by. In data exploration, group by is frequently used, particularly in conjunction with summarize for continuous variables and count for nominal variables. Group by organizes data based on variable values. We'll try using a new variable, heel pro bone, which denotes back pain presence, 1 for present, 2 for absent. Given the high incidence of missing or non-responses, we'll exclude instances where heel prob 1 is unresponsive. In a missing values can be identified with is, na, variable. Let's start with count. Next, we'll check how many people are complaining about back pain by sex group. We'll check how many people are complaining about back pain by sex group. Now, let's examine the ratios by age. It's difficult to understand at a glance. So, what should we do? It would be good to calculate ratios through mutate. Group by age. This function groups the data by the adject age group column. Grouping is a powerful way to perform calculations within each group separately. Count, heel, pro bone, after grouping. Count tallies the number of occurrences of each unique value in the heel prob 1 column within each age group. Mutate, prob equals n/sum in here. Mutate is used to create a new column prob. which is the proportion of each heel prob one value within its respective age group. Finally, we remain only interesting value of back pain. Now back pain is one of heel prob. How about that? Can you find the trend of the prevalence of back pain according to age group? Good job. Let's move next step.